Hello students, today we will learn about the metals and the non-metals, which is your chapter number 4, right? In the metals and non-metals, basically we will look into two categories. They are first their physical properties and next is their chemical properties. So let's begin your chapter number 4, that is material, metals and non-metals, right? So first we are looking into the physical properties. Physical properties, right? In the physical properties, the point which we are looking into, the first is hardness. Hardness. If we write here metals and here non-metals. So the first point is hardness. Metals are generally hard and non-metals are generally not hard, right? Or they are soft. The next thing over which we are looking into, the next property is conductivity. Conductivity. Metals are good conductor of heat and electricity, good conductor. That is why they are used as a wire to conduct the electricity. Similarly, they are poor conductor or insulator, you can say, right? All the metals are good conductor of electricity and most of the non-metals are insulator or bad conductor of electricity, but one of the exception is there, that is graphite. Graphite being a non-metal is good conductor. Sometimes this question is asked in the exam. Now the next property is sonorous. Sonorous means ability to produce ringing sound. When you strike hard on the metal, it produces ringing sound. That is why they are used in the bicycle and in other vehicles to produce as a ring, right? And they are, if we are talking about non-metals, they are non-sonorous. The fourth one is malleability. Malleability, ability to change into sheets. Like aluminium foil, you have seen aluminium is a metal, so metals are having the ability to change into the sheet. When metals have been beaten hard, they can be converted or changes into the sheets, right? But non-metals cannot be changes into the sheets. They are brittle. They are brittle. Brittle means if we strike hard on the non-metals, they can be spread like the powder. They can be converted into the powder, but they cannot be converted into the wires or into the metal sheets. Now, next property is ductility. Metal can also be changes or converted into the wires, right? Into the wires, here they convert into the sheets. So metals are ductile but non-metals are non-ductile. Okay, now I hope that state की बात कर लेते, physical state. All the metals are present in the solid state. Most of the metal are present in the solid state, right? But mercury present in the liquid state. This is exception. Getting it? Mercury present in the form of liquid. All the metals generally found in the solid state, but mercury, which is used in thermometer, you might have seen thermometer at which doctor takes us body temperature. So they are the mercury is available in the form of liquid, right? All the non-metals are present in the gaseous form, exception bromine. Bromine present in the form of liquid. Is it clear? So these are the points over which we are looking into. They are the physical properties of the metals and the non-metals. You can note down also. On the basis of 6 points, you can easily differentiate the physical property of metal and non-metal, their hardness, conductivity, sonorous, malleability, ductility, and physical state. Is it clear? Now we are moving to the next property, which is also called a chemical properties. Now, in the chemical properties, we will look into how metal and non-metals are reacting with water, oxygen, acid, and base. Is it clear? So first, we will look into how metals are reaction with water, right? When metal react with water, here you can write metal react with water, they produce base, right? Now all the metals are not reacting with reaction with water, all the metals are not reacting with water. Sodium, here you can write sodium, or potassium, they are active metals, so they react vigorously. As you pour the sodium into the water, it vigorously react with the water and forming sodium hydroxide. Example हम यहाँ ले लेते हैं. Example, sodium when react with water form sodium hydroxide. What it is formed? Sodium hydroxide. You are in the 8th class, you are not asked to write the chemical formula, right? Simply you need to write the equation in the form of word equation you need to write. So again you can see here, when metal react with water, they form base. Example, when sodium react with water, form sodium hydroxide, right? Sodium hydroxide. Non-metals generally they do not react with water. Is that clear? Now the next reaction with acid. When metal react with acid, produce salt plus hydrogen gas. What it produce? Hydrogen gas. Okay, but non-metals generally do not react with an acid. Is it clear? Now moving ahead, the third reaction with base. इसका एग्जाम्पल देख लो एक बार. मेटल, फॉर एग्जाम्पल यू अगेन हैव टेकन सोडियम, react with hydrochloric acid, forms sodium chloride plus hydrogen gas, right? Now the next one is reaction with base. When metal react with base, they form base only. For example, again you can take sodium. When react with calcium hydroxide or sodium hydroxide itself, you can take sodium hydroxide. They form sodium hydroxide only. But in the case of non-metal, when non-metal react with base, they form salt plus water. What they form? Salt plus water. How it is going to be clear? Suppose base is sodium hydroxide you have taken, and this is sodium hydroxide, the formula of sodium hydroxide, it is a base. And chlorine, Cl2, this is chlorine, and forming sodium chloride plus water. Is that clear? You are not allowed to write in this case, but here this is what the chemical equation. You can write base when react with chlorine forming sodium chloride, that is a salt, and water. Now moving into the last reaction in this category, which is very important one, reaction with oxygen. When metal react with oxygen, forms metal oxide. This is first situation, right? For example, when sodium react with oxygen, forms sodium oxide. Clear? This is first equation. Second equation, this is metal oxide. It is metal oxides are basic in nature. How you are going to prove it? So simply you will take the metal oxide, right? Metal oxide, example is sodium oxide. Sodium oxide, when dissolved in water, right, they produce sodium hydroxide, and sodium hydroxide is a base. Clear? So this is why metal oxides are basic in nature. Is that clear? Basic in nature. Now, reaction of non-metal with base. When non-metal react with oxygen, produce non-metallic oxide. For example, see, sir, carbon is a non-metal. When react with oxygen, here you can write carbon. When reacting with oxygen, forming carbon dioxide. Right? Now, the next thing is, this is first point. Next point is non-metallic metal oxides are acidic in nature. How you are going to prove it? Non-metallic oxide we can take carbon dioxide when dissolved in water gives carbonic acid. Right? So they produce acid, that is why they are acidic in nature. Is it clear, students? One more thing which is left is reaction of non-metals with base. Right? So with the base, reaction of non-metal with base is generally complex. Right? This is enough for you to write. But even though if you want to take the example, you can take the example like sodium hydroxide. Sodium hydroxide when react with chlorine gas, it produces sodium chloride plus sodium chlorate plus water. These three things have been formed. This is a complex type of reaction. In the chemical equation form also you can see when sodium hydroxide react with chlorine gas, it produces sodium chloride, sodium chlorate plus water. So there are three things have been formed: sodium chloride NaCl plus sodium chlorate NaClO3 and water have been formed. So this is what kind of complex reaction for you people who are in the 8th standard. That is why simply you can mention the reaction of non-metals with base are complex. Or if you want to take the example, you can then note down the example also. Now, in the last topic, very important one, the displacement reaction. And most of the students are confused in this topic, so watch it very carefully. What is displacement reaction? Displacement means something is substituted by another thing, right? So more reactive metals, right? More reactive metals displaces less reactive metals from its salt solution. So this is called displacement reaction. Now how you are going to identify that which metal is more reactive and which metal is less reactive? And for that you need to learn the activity series, right? Here is the activity series. What is activity series basically? Basically in the activity series, metals have been arranged in the order of their activity, how much they are reactive, right? So the most reactive metal have been placed at the top, and then the sequence comes on, like highest reactivity of in the metals is potassium, then sodium, then calcium, magnesium, and so on, right? So they have been arranged in the order of their activity, and the activity order of the metal have been decreases downward, right? So this is what the activity series you can note down and you can learn also. Here you can see if you are comparing with the zinc and potassium, which one is more reactive? Of course, potassium is more reactive than the zinc. If you are comparing with the iron and copper, which one is more reactive? The iron is more reactive than copper. In your syllabus, they are most of the time zinc, iron, copper, these three substituted, or most of the question have been formed from these three metals. right? So you just remember, zinc is more reactive than iron and copper. Iron is more reactive than copper but less reactive than zinc, and copper is least reactive than zinc and iron. Now coming to the topic, what is displacement reaction? Displacement reaction is when more reactive metal displaces less reactive metal from its salt solution, is called displacement reaction. Let's see the example. When we have taken the copper sulfate solution, right, it is blue in color, blue color. When you add zinc into it, it will form zinc sulfate, zinc sulfate plus copper will be free, copper will be free. This is what the reaction, right? This is the reaction. And what is the color of zinc sulfate? Color of zinc sulfate is colorless. Copper is less reactive than zinc. Then what will happen? Zinc will displace the copper from here and comes over here, so it will form zinc sulfate. Zinc sulfate have been formed and copper will be free. The solution of copper sulfate is blue, but when the reaction is taken place, the solution of zinc sulfate will be colorless. Let's see the practical example, right? Suppose I have this copper sulfate solution. Here you can see this is which color it is? It is in the color of blue. Now when I am adding zinc into this solution, you can see the changes. This is zinc is added now. Now when the zinc is added into the solution, let's see the color. It is the color of zinc sulfate. Slowly the zinc sulfate will be settled down. You can see the changes in the color, right? See, it is changes into colorless solution. Is it clear? It is clear, visible. So this is what the zinc sulfate is formed. This is what the displacement reaction. What is displacement reaction? Displacement reaction when more reactive metal, more reactive metal displaces less reactive metal from its salt solution is called displacement reaction. Activity also I have made you to understand. And now with this we come to end of the chapter. Thank you so much for watching. Enjoy the video. Any doubt you can just write down to me. I will clear your answers. Thank you.